So in this new video, that is the last video of quantum physics, we are going to study the photoelectric effect briefly and the Compton effect. So what is photoelectric effect? As you all can see, I have drawn an experimental setup for the study of photoelectric effect. So this here is the window that is denoted by W, from which radiation enters, and this is an ammeter that measures in milliammeter, and this is a voltmeter. So when electromagnetic radiations, that in EM radiations of sufficiently high frequencies, fall on a metal surface, the electrons are emitted, and this phenomena is known as the photoelectric effect, where photo refers to light and electric refers to the electrons emitted. So the basic phenomena is that light of a certain frequency strikes onto a metal plate. So you can see I have drawn here, this is the metal plate P. So when due to the striking of light, the electrons gets enough energy and gets excited, the electrons are emitted in this direction. This phenomenon is known as the photoelectric effect. The current produced in a circuit due to emission of electrons from the metal surface by the effect of light, that is due to photoelectric effect, is known as photocurrent. So due to the flow of electron, a current generates in the circuits, and this milliammeter deflects. Hence, this current is known as photocurrent. So this is basically the gist of the photoelectric effect. So what is, we need to know some definitions, that is stopping potential. So what is, let me write that for you. So friends, here is the definition of stopping potential for you all. So stopping potential is denoted by V naught. So it is the maximum cut start. So it is the minimum retarding potential for which the photocurrent becomes zero, or photocurrent tends to zero. So in that case, the photoelectrons with maximum kinetic energy that is emitted from the plate are just able to reach the anode. So the work done by stopping potential is equal to the maximum kinetic energy of the electrons. Therefore, we can say E into V naught, that is equal to half m into V max square. Thus, stopping potential gives the estimate of the maximum kinetic energy of the emitted photoelectrons. So another important definition is threshold frequency. Threshold frequency is the minimum frequency of light to start the flow. That is the minimum frequency that the light must have to strike the electrons with that much energy, so the electron can start flowing and the current starts to flow. That is known as the threshold frequency. So now let us just summon up some laws of photoelectric emissions for you. So these I have noted down are some laws, or you can say experimental data or inferences that we have obtained, or we should follow, or must be followed to get these results. That is, flow will start if the frequency that is nu is greater than equal to the threshold frequency. And that is only the definition of threshold frequency, that the frequency, the minimum frequency after which, attending which the flow of electrons starts. Number 2 is there is no time lag in between the falling of light into the plate, that is the striking of light rays into the plate, and the flow of electrons. It starts instantaneously. So the process is instantaneous. Number 3 is the current, that is the intensity of the current, is proportional to the intensity of the light, not to the frequency. It is not dependent on the frequency. So current depends on the intensity of light. But stopping potential, that is V naught, increases with increase in frequency of light. So V naught, that is stopping potential of the metal, depends upon the frequency of the light falling to it. Now, before summarizing the topic of photoelectric effect, an important definition is left, that is of work function. So what is work function basically? Work function is the minimum energy that is required to liberate an electron from the metal surface. That is the energy that is required to extract an electron from the metal surface. If we see, or we can just admit that when a photon of energy h nu is absorbed by an electron, an amount of energy is at least equal to W naught that we consider is used to liberate the electron from the metal surface. And the rest of the electron, that is h nu minus W naught, which is absorbed by the outgoing electron of mass m. So we can write the equation as h nu minus W naught is equal to half mv max square, or we can write h nu equal to h nu naught plus half m v max square, where you can say W naught is equal to h nu naught. So this is an important equation. This is the total energy, this is the energy required to extract an electron, and this is the energy that is absorbed by the electron and converted into kinetic energy of the electron, that is to flow of the electron. So this is the work function. So with this, we can summon the topic of photoelectric effect for now. But let me tell you one thing, why the study of photoelectric effect is needed. Because photoelectric effect proves the wave particle duality, and photoelectric effect is the proof of particle nature of electromagnetic waves. Hence photoelectric effect must be studied. So now let us start with the last and final topic, that is Compton effect. So basically the idea of Compton effect is very simple, that is transfer of energy and momentum. So if this is a particle, so when a photon of high energy, okay, let this be the photon of high energy, the energy let it be h nu, collides with the free or loosely bound electron of the scatterer in the experiment. So let this be the electron, and this photon collide with this electron that is freely bound and it is of high energy. So the electron is at rest, it transfers some energy to the electron. This h nu energy gets transferred in some amount into the electron. So if we consider the transferred amount to be h nu dash, and consequently a greater wavelength is taken place by the electron, so the energy taken by this electron is smaller than h nu and the wavelength is greater than the photon. The observed change in wavelength of scattered photon by considering the elastic collisions between the incident photon and the free electrons of the scattered material is known as Compton effect. So the photon is scattered in a different direction and the electron is also forced to move in a different direction. So this effect is known as Compton effect. If this is the reference line, the scattering angle of photon, let it be phi, and the scattering angle of electron, let it be theta. So this is, we also can call as target electron. Here P1, that is momentum, can be found out by h nu by c. Now applying the law of momentum conservation along the perpendicular to the direction of incidence, we get h nu by c plus 0 is equal to h nu dash by c cos of phi, that is h nu dash by c cos of phi, that is in this direction, plus p cos of theta along the same direction. So 0 is equal to h nu dash by c sine of phi minus p sine of theta. This is one equation and this is another equation. This is perpendicular to the direction. Here we consider P as the momentum of the recoil electron. So from the equation we can find, or we can conclude, that Pc cos of theta is equal to h nu minus h nu dash cos of phi. And similarly Pc sin of theta is equal to h nu dash sin of phi. We get these pairs of equation. If we square and add both of them, we will get Pc whole square is equal to h nu whole square minus 2h nu into h nu dash cos of phi plus h nu dash whole square. This is the equation we are getting. Again, applying the law of energy conservation, we can say E double dash, that is, we get the energy of the recoil electron, E double dash equal to kinetic energy of recoil electron plus rest mass energy of the electron. So what is kinetic energy of the recoil electron? It is the energy transferred to the electron by the photon plus the rest mass. So we can write it as h nu minus h nu naught dash plus m naught c square. So we can write in this form. Again, E dash can be written in the form of p square c square plus m naught square c to the power 4 whole root over. Sorry. So root over. So what we can conclude from these equations? We can say p square c square plus m naught square c to the power 4 is equal to h nu minus h nu dash plus m naught c square whole square. Now if we expand this and solve further, we will be getting this equation: p square c square is equal to h nu whole square minus 2h nu into h nu dash plus h nu dash whole square plus 2m naught c square into h nu minus h nu dash. So we get from these equations, that is 2m naught c square into h nu minus h nu dash is equal to 2 h nu into h nu dash minus 2 h nu into h nu dash cos of phi. So after solving this, what we will get? We will be getting 1 by nu dash minus 1 by nu equal to h by m naught c square into 1 minus cos of phi. So we will be getting this in terms of frequency. And another form, if we substitute this by c by lambda dash and this by c by lambda, we will be getting lambda dash minus lambda is equal to h by m naught c into 1 minus cos of phi. This is in terms of lambda and this is in terms of nu, that is frequency. So these equations give the change in wavelength or Compton shift of the scattered photon by a particle of rest mass m naught. So previously we have calculated the formula or derived the formula to take out the Compton wavelength, that is lambda dash minus lambda equal to h by m naught c into 1 minus cos of phi. With this we can find out the Compton wavelength. Now we don't need to do the long derivations for the direction of recoil electron or energy of recoil electron. We only need to memorize the formula for examination point of view, since in our syllabus only Compton wavelength is there. So what will be the Compton wavelength? Since the maximum value of cos phi is equal to 1, the wavelength of the scattered photon is always greater than the incident photon. This change is independent of the wavelength lambda of the incident photon, and the quantity h by m naught c, that is equal to lambda c, is known as Compton wavelength. So what is the definition of Compton wavelength? Important definition, that is h by m naught c, that is denoted by lambda c. So this is the change in the independence of the wavelength lambda of the incident photon and the quantity. This is known as Compton wavelength. So the equation gives the conclusion that when phi equal to 0, that is when phi equal to 0, then lambda dash minus lambda equal to 0. There is no scattering. Number 2 is when phi equal to pi by 2, then lambda dash minus lambda is equal to h by m naught c, that is equal to lambda c. That is Compton wavelength. So this is the condition when Compton wavelength takes place, that is phi equal to pi by 2. So Compton shift can be measured in this case. Compton shift, let it denoted by del lambda, that is equal to lambda dash minus lambda, that is equal to h by m naught c into 1 minus cos of phi. So we can write the values of it as 0.02427 into 1 minus cos of phi. Another condition is that when phi equal to 180 degree, then lambda dash minus lambda is equal to 2h by m naught c. That is, the wavelength change will be twice of the Compton wavelength, and this is the maximum possible shift. This is the condition of maximum shift. So now let me write the equations for you, that is to remember from the examination point of view. So the equation, first I am writing of direction of recoil electron. So the frequency of scattered photon can be found out from this formula, that is nu dash is equal to nu by 1 plus h nu by m naught c square into 2 sine square phi by 2. This is the formula for direction of recoil. Under the topic direction of recoil, this is the formula for the frequency of scattered photon, and the direction also includes tan of theta, by which we can find the direction. The tan of theta must be equal to cot of phi by 2 by 1 plus h nu by m naught c square. So this is the direction of recoil. Now we will be seeing the equation for energy of the recoil electron. So energy of the recoil electron can be given by kinetic energy plus rest mass energy. That is, we come to the conclusion as h square nu square by m naught c square into 1 minus cos phi by 1 plus h nu by m naught c square into 1 minus cos phi plus the rest mass, that is m naught c square. So this is the equation for energy. So with this we have come to the end of this topic of quantum physics. In the next videos we will be learning about de Broglie's hypothesis and Heisenberg's uncertainty principle. Thank you.